Jupiter orbit distant suns in far-off solar systems, something mankind really couldn't prove until now. And where there are Jupiters, there may be Earths. These discoveries have thrown other planet seekers into action. In the Jet Propulsion Labs of NASA, the National Aeronautics and Space Administration, technicians look like they're dancing for joy. But in reality, they're hard at work on a new kind of telescope called an interferometer. When perfected early in the next century, it will be launched into space where the smallest vibration could affect its precision alignment. These men are finding ways to stabilize the setup and cancel out any vibrations. The space-based interferometer will probe deeper than ever before into neighboring solar systems, searching for planets 300 times smaller than those found by Butler and Marcy. Planets more like Earth.
And we've always wondered, are we alone? What are the forces that led to the creation of life in the universe? And it's an area where there are lots of questions and very few answers.
Charles Beichmann heads Planet Finder, part of NASA's Origins project to find other worlds.
And the goal of Origins is over the next 10 to 20 years to actually characterize the planets around other stars. Find out, are there other Earth-like systems? Do those Earth-like planets have an atmosphere? Does that atmosphere have the temperature, the density, the chemical composition to either support life, or even is there evidence for life?
At the moment, the way to find new planets is to analyze the movement of stars. The space interferometer will take things a giant step further. By interfering or cancelling out the incredibly bright light of the star, it will reveal the fainter line of any planet circling it.
As you can see here, as we dim the spotlight, as we dim out the sun, the faint planet can be seen orbiting around the star. The light from the star itself has been rejected by the interferometer, and you can actually make out the pale blue dot of the planet.
But the big question is whether there is life on those distant worlds. Once NASA can see the planet, analysis of its light will tell them how hospitable a place it is.
And with a few spectral tracers, a few atmospheric tracers, we can find that out. Is it cold and barren like Mars? Is it a very thin atmosphere? Is it very, very hot and a runaway greenhouse like Venus? Or is it somewhere in between those two, something like our own Earth?
To get the high degree of magnification needed to find and study Earth-sized planets, a traditional mirror telescope would have to be huge, over 100 meters. That's 10 times the diameter of Earth's most powerful telescopes, like this structure at Kank in Hawaii. Such a big telescope would be cumbersome to launch into space, but with a clever mirror trick, astronomers have found the way around the problem. The interferometer uses a pair of small telescopes placed at either end of a beam as long as an American football field. As it rotates, it traces a path equal to the diameter of a huge telescope mirror, allowing it to see just as much detail. The more telescopes added to the system, the better the view of other worlds. They could be home to creatures only dreamed of in our imaginations. At Mount Palomar in California, a prototype interferometer is being tested. Michael Chow, the world's leading expert on optical interferometry, walks along one arm of the telescope. An inside look at this interferometer reveals more mirrors. From two telescopes around 100 meters apart, starlight is collected and sent to a beam switch yard, a series of precisely angled mirrors and beam splitters. These delay lines, little mirror trolleys, move back and forth to equalize the paths of the incoming light from both telescopes. The light is sent into a beam combiner through more mirrors, where the light waves interfere or cancel out. The remaining light is picked up by a detector cooled by liquid nitrogen to an unbelievable 77 degrees Kelvin or minus 176 degrees centigrade. This allows scientists to test the device in an atmosphere that mimics the freezing conditions of space.
The difference between doing this on the ground and going into space is on the ground we can see things like Jupiter and Uranus mass planets, and in the space we would then be looking for Earth-like planets.
Space is where NASA plans to put one of these interferometers